Hey guys, welcome to my channel, and today I'm recording 5070 paper 2 of October November 2021. This paper is of 1 hour 30 minutes. I've already solved its previous parts, that is part 1, 2 and 3. So make sure you check it out, and also I'm going to be uploading more parts really soon. So this is one of the second last part for this video, and then I'll have a last part for it. So make sure you subscribe and ring the bell icon to be updated with every kind of video I upload as soon as I post it. So without any further ado, let's get started. I've already solved section A, many questions from it till question number 6 I've solved it. Now we're going to start question number 7. Section B, answer 3 questions from this section in the spaces provided. The total mark for this section is 30. Question number 7 says sodium is a metal in group 1 of the periodic table. Diamond carbon is a non-metal which is a good conductor of heat. Part A says state 2 differences in the physical properties of sodium and diamond. We need to find the 2 different physical properties between sodium and diamond. So here diamond is also made up of carbon, which is a non-metal, as well as sodium is also sodium is a metal. Basically sodium is a metal and carbon is a non-metal. Since diamond is made up of carbon, so diamond is also a non-metal. So we need to find 2 physical differences between them. You can write basic differences between a metal and a non-metal related to it, or you can also keep it specific to sodium and diamond if you wish. So if we look at metal, that is sodium. So sodium has the ability to conduct electricity while diamond does not. And sodium is malleable while diamond isn't malleable, it's brittle. So you can write whatever you want to from these points. You can also mention that sodium is soft, diamond is a very hard material, and all this. So moving on to part B, an ion of sodium has a symbol of Na plus 2311 as its proton number and its atomic mass. Reduce the number of protons, neutrons and electrons in this ion. Number of protons, very basic, very simple. This is the number of protons, that is 11. And number of neutrons is 23 minus 11, which will make it 12. Why 23 minus 11? Because 23 is the atomic mass. And what is atomic mass? Atomic mass is the total number of protons and the total number of neutrons. If you want to find neutrons, we need to subtract the protons from it, that is 11 given to us over here. So 23 minus 11 is 12, so number of neutrons will be 12, and number of electrons, usually if you do not see this plus, it's going to be 11 because proton and neutrons are equal in a neutral atom. However, we have an ion with us. As the question itself says, an ion of sodium has a symbol of Na plus. So if we have a positive charge, that means one electron will be, you can say, subtracted. That means from 11 we are going to subtract 1, which will make it 10. So number of electrons will be 10. Moving on to part C, sodium reacts with nitrogen to form sodium nitrite. Complete the equation for this reaction. Sodium reacts with nitrogen to form, so we are first of all going to write nitrogen over here, because that is what sodium is basically reacting with. So this is our nitrogen with us. I have left some space so that in case in balancing we require to write any number over here. So if we see Na 3N, so we only have one N over here yet. So if we have to balance it and we put 3 over here, if for instance, let's do trial and error, if we put 3 Na over here, so nitrogen will not be balanced because we have 2 nitrogens on one side and 1 nitrogen at the other side, so it's not going to be 3. Likewise, it cannot even be 4 since Na3 is an odd number. We have 3 over here, so it's going to be 6, since 3 2s are 6, so 6 over here and 2 Na3N over here, which will make it 2 Na3 will be 6 Na, sodium 6 sodium, and N2 2 N2. So we do not need to put anything over here since it's already balanced now. Moving on to part D, when carbon is heated with steam in a closed container, an equilibrium mixture is formed. The forward reaction is endothermic. Describe and explain the effect, if any, on the position of equilibrium when the temperature is increased. When the temperature is increased, since the forward reaction is endothermic, that means the equilibrium will move towards the right side. It will be towards the forward side or towards the product side. Alright. And why will it be in this case? Because it's an endothermic reaction, so more heat will be absorbed, hence more product will be formed. Because this side is endothermic, so the opposite side will be exothermic, which is common sense. So this is how we are going to be doing this question. Moving on to part 2, describe and explain the effect, if any, on the position of equilibrium when the pressure is decreased. When the pressure is decreased, let's again go to the equation. Since we have 1 1 1 is to 1, so equilibrium will, since we're talking about pressure over here, so equilibrium will move towards right, that is again the product side. All right, and this is about pressure being decreased. All right, as I just said, decrease. So since we have more of gas moles over here, that is why we only have 1 mole of gas, we can say over here. H2 is only in the gas form, so, and we have 2 over here, so that is why more product will be formed and the reaction will move towards right. And I just told you the reason, because of moles of gases. So that is it for question number 7. Moving on to question number 8. The structure of an organic compound T is shown. Reduce the molecular formula of compound T. Okay, also in this question I wanted to mention, I forgot to tell you a general rule over here. Whenever we increase the temperature, the pressure will always move towards the side where there is lesser mole, and whenever we decrease the pressure, the uh, equilibrium will move towards the side where there is greater moles of gases. Remember to always see gases. Okay, so this was a general statement, the concept that I wanted to tell you behind it, and besides it you can frame the answer on your own. Moving on to question number 8, the structure of an organic compound T is shown. Reduce the molecular formula of compound T. The molecular formula of compound T is going to be, if we see over here, it will be C3 H6 and we have 1 O, so 1 O. Alright, since we have 1 2 2 3 carbons, 1 2 3 carbons, 1 2 3 4 5 6 hydrogens and 1 oxygen. Pretty simple question. Moving on to part B. Compound T is a colorless liquid. State the color change when excess compound T is added to aqueous bromine. So if we have compound T reacting with bromine, so it will turn from orange to colorless. Why? Because compound T has double bonds. That is why it will change from colorless to, from orange to colorless, brown to colorless, orange to colorless. Moving on to part C. Compound T can be oxidized to a carboxylic acid. Suggest a suitable agent for this reaction. A suitable reagent for this reaction will be potassium magnate 7, because here we are talking about oxidation, that is why oxidizing agent is usually potassium magnate 7. Part D says compound T can be polymerized. Draw the partial structure of the polymer of compound T. Show 2 repeat units. So this can be polymerized. That means it can, the addition reaction can take place. That is what we are talking. Not addition reaction. Addition polymerization. I'm sorry. It will be addition polymerization. So let's draw the repeat structures for it. Alright, so as we can see over here, this is 1 unit, and then this is a second unit. Alright, so moving on to part E, compound T reacts with methanoic acid HCOOH to form an ester. Complete the structure of this ester to show all the atoms and all the bonds. So let's complete the structure. This is basically, it reacts, compound T is being reacted with methanoic acid. This is a reaction that is being taken place, and it will form an ester. So here if we see, we have CH and we need to show ester bond over here mainly. This is the goal over here that we have. If we react it with methanoic acid, that means this part, let's do it. Alright, so what I was just saying here right now, let me to just tell you what I meant that I was just saying right now, was that this part is from the compound, this organic compound, and then this one is from methanoic acid, and they're forming an ester. So this will together be able, okay, so as we can see over here, now an ester bond is formed over here since it has reacted with methanoic acid. It's pretty simple, and this is how it will be done. Moving on to part F, methanoic acid is a weak acid, hydrochloric acid is a strong acid. Part 1 says give the formula of the positive ion that is present in all acids. The positive ion present in all acids is H plus. And moving on to part 2, explain why the rate of reaction of 1 mole per dm cube methanoic acid with magnesium is less than the rate of reaction of 1 mole per dm cube of hydrochloric acid with magnesium. It is because methanoic acid has lesser concentration of H plus ions, hence this is what happens. This is how it will be solved. It's pretty simple question. We are mainly talking about what is a stronger acid and a weaker acid. Moving on to part G, construct the equation for the reaction for methanoic acid with magnesium. So let's construct the equation. Alright, so this is the reaction, and you must have noticed in between I erased Mg from here, magnesium, and I put it over here because if we talk about the bond formation or in which pattern it will be formed, so it will be Mg OOCH. So if you are writing it Mg, if you're writing Mg over here, so make sure to write OOCH and then 2. But since I was writing HCOO, so I had to mention Mg in the end. That's all. It's not a big deal. Alright, so this is it for this question as well as this is it for this paper. I will be solving its last part in the next video really soon, so make sure to ring the bell icon so you're updated as soon as I post it. This is it for the video. Thank you so much for watching. Hope you found it helpful. Make sure to like, subscribe and comment if you have any query. Thank you so much for watching and best of luck for your exams.